Good morning, students. Welcome back to science class on the chapter electricity. Today we'll discuss last portion of this chapter. Okay, that is heating effect of electric current. Okay, uh, I think you have seen and you have felt. If you use one electric agent, for example, say mobile, if you use that mobile for a long time, so after half an hour or after 1 hour, you can feel heat. Correct? Yes. If you take, fan, for example, take a TV. Okay. So if you watch that TV for 1 hour or 2 hours, so when you touch that TV, that body of that TV, you can feel heat. Okay, and if you touch these bulbs, correct, so after some time, if you use for some 1 hour or 2 hour, so definitely you can feel heat, correct. See, actually we are not supplying any kind of heat, correct. If you take mobile, just we are supplying what energy, that is we are supplying potential energy, means we are just sending voltage, correct. We are not what, we are not sending heat, but you will when you touch those devices, you can feel heat, right? You will feel heat. Why? Okay, see here, for example, you are say just you are sending 100% energy. Okay, you are sending 100% energy to one device. Okay, so here, do you think that? So here we can get the 100% of this energy. Is it useful for 100%? No, right? See here, whatever we supply energy, in that only amount of energy is useful for us. Okay, then what about remaining person? Where does this go? Okay, so that the remaining energy which is converting into heat. Okay, already I have studied about resistance. What is resistance? It is a flow of opposition of electric current. For example, when you pass electrons through wire, what will happen? It faces some collision, correct? So when moving from one side to another side, some electrons they will collide with neighboring atoms. Okay, so in one second millions of electrons passes, correct, millions billions of electron passes at that time. So here most of so many electrons they will collide with the neighboring atoms. Okay, so due to that collision, what happens? So due to that collision, heat arises in that conductor, or heat is developed in that conductor. So that's why we can, after if you use those just for a long time, then you can feel the heat. So clear it? Why that heat is developed in the conductor, or why heat is produced in the conductor? That is due to the collision of atom, due to the collision of electrons. Okay, so clear, right? Hope you, why if you use the electric devices for long term, why if you touch those devices you can feel heat. Why that heat is produced? That is due to the collision of electrons. Okay. Next, so now definitely if you use any devices, if you use for some time, definitely the heat produces in that conductor. Why? Because the collision, it is what, it is a natural process. Okay, when you pass if you use aluminum, copper, whatever you use conductor, if you pass electrons, so definitely there is a collision occurs. So definitely the heat produces in those conductors. Okay, now is it possible? So now we can convert that heat. See, we can take that heat for our useful works. We use heat. Okay, we use wood to boil the water. Okay, so now here I am using this device. Okay, now I will use for some time. So heat is produced in this conductor. So now can I use this heat as for other works? Okay, yes, definitely. But if you use mobile, for example, say you will play 1 hour. Okay, so you in that mobile using that heat. Okay, will you boil the water? No, right? Because it is very less. Okay, see why that heat is produced. That is due to the collision. Okay, now I will forcibly, what I want to create that heat in that conductor. Now I need more heat. See, I have one conductor. I am getting very less amount of heat. Okay. Now I need more heat from this conductor. How to get more heat from that conductor? Which means I have to increase that collision. Correct? If you increase the collision, then heat increases, right? Okay. So for that, we use some materials. We use some materials, say alloys and other. Okay. Because the boiling point is very high. Okay. We use some materials, means we are forcibly colliding. We are creating the collision. Okay, see, you have a conductor. If you want more heat from that conductor, then while passing electrons, you have to increase that collision. Then only you will get more heat. Otherwise, you won't. Okay, so when you pass current through one conductor, so if you use for a long time, so due to that collision, heat is produces in that conductor. So we call that as heating effect of electric current. Hope clear, right? What is the heating effect of electric current? So when you pass electricity in one conductor, so due to the collision of atom, due to the collision of electrons, okay, so heat is produced in that conductor. So this process is known as heating effect of electric current. Okay. Now, see here. Now I want to calculate what the heat in that conductor. You have a simple method. While touching, if you feel more heat, then you can say the heat is more. If you feel less heat, then you can feel less heat. Okay. Okay, see here, when you touch that one, if you feel more, then you can say so that it is more. Okay, but it's not the exact way, right? So now I want to calculate heat produced in the conductor. Okay, or how to increase the heat in the conductor, how to decrease the heat in the conductor. Okay, so to calculate for that, we have one formula. Okay, so now let's derive that. What is the formula to calculate how to calculate that heat produced in the conductor? Okay, see here. So now just consider one conductor. Okay, its resistance is a R. So connected to one battery cell. Yes, see here, so when you turn on this key, what will happen? Electrons, they will move from negative side to positive side through this resistor. Okay, so now I am passing voltage, right? So I V. Why? Because I am passing, I don't know whether it is 2 volt or 3 volt, whatever it is. Right? When you don't know, for unknown values, you will take correct. So but I am sending what I am supplying some amount of voltage, I don't know, so that's why take voltage potential difference or voltage as V. Okay, next, when you pass voltage, current flows, right? Current, so I'll take that current as I. Okay, do you know, right, what is current? What is the current? It's the rate of flow of electric charges. So current flows. Okay, next, this is a conductor. In the beginning class, in the previous class, I have told all the conductors, they will consist of some amount, some appreciable resistance. Okay, I don't know whether it is 2 ohm, 3 ohm, 1 k, whatever, but I will take the resistance of that conductor as R. Clear? See here, when you connect battery here, she was sending voltage, which means what happens here? Here electrons will move, right, from negative side to positive side. When you turn on that key, electrons will move from negative to positive. Okay, so I don't know, I am sending whether one electron or 2 electrons, 3 electrons. For that I use Q. Q means what? Number of electrons. I am sending some electrons. They will flow from negative side to positive side. Okay. And see here these electrons they will move in a given time t. Okay, then once again, they will take any on that t within a fraction of second. Negative side to positive side. Time is very less. I don't know, but I will take that time as t. Okay. Yes. Here your voltage is V and current as I, resistance R, and some electrons they will move from negative side to positive. For that we have taken number of electrons, that is Q and time T. Okay, but how to start? That is important, right? See, we can't write directly. You have studied last year, right? V is equals to U plus AT. Okay, so to do that you have considered one graph. Here that object changes its velocity from initial to final like that. Using that one, we have derived that one. So now here also same. So now here our work is to prove that H is equals to I square into R into T. Tell me how to start. CI. Okay. So here what is the function of this battery here? It will supply energy, it will send some electrons. So which means it will do a work. Okay, correct. So now so I will take work done by that battery as W. Okay, this formula. So to calculate the voltage potential difference, V is equals to W divided by Q. Correct. So to calculate voltage, okay, you are studied to calculate voltage. Voltage V is equals to work done divided by charge, number of charges. Okay, already know what is the potential difference. Now see here, can I write this equation as W is equals to V into Q? Can I write? We know the potential difference form. What is that? So potential difference is equals to work done divided by Q. Okay, the work required to move electric charges from one point to another point. So that is called potential energy. So using that one, we can write W is equals to V into Q. Okay. Yes. Now see here. For example, see here you are calculating. Here you know the V value, and here you know number of Q charges. So definitely you will get W value, right? Okay, suppose say you get 1 joule. So what is the meaning of 1 joule here? Which means here this battery it should do 1 joule of work. Suppose if it is well calculated, you get 100 joule. What is that? So this battery it is doing 100 joule of work. Clear? Okay. You have discussed one problem. See here that in your textbook example 12.2, how much work is done? See, listen carefully. How much work is done moving a charge of 2 coulomb? Moving a charge of 2 coulomb. Moving a charge of 2 coulomb across 2 points, having a potential difference is 12 volt. Having a potential difference is 12 volt. Okay, so here we have given number of charge, that is Q equal to 2C, and volt potential difference is equal to 12 volt. You know the formula, that is V is equals to W by Q, or W is equals to V into Q. Okay, so 2 into 12, so here you will get 24 joule. So which means that battery it will do 24 joule of work. Now here I don't know the values. I don't know whether it is 100 joule or 24 joule or 2 joule. I don't know. But here I got work done equal to V into Q. What is the meaning? Here that battery it should do 100 joule of work. Here it should do 24 joule of work. But here I got W equal to V into Q. What is the meaning? Here this battery it should do work. That work which should equal to V into Q. Means V into Q, that much work it should do. Here just as we don't know, I don't know the values, right? Correct. So that's why here we are using V into Q. if you get a values like this, then clearly you can say 100 joule of work is required, 24 joule of work is required. Okay, but here I don't know whether it is a 1 joule of work or 2 joule work or 3 joule. But here this battery should supply energy, correct? That energy is should equal to V into Q. Clear? Yes. So then what is the next step? Yes. See here. So using this expression V is equals to W by Q. So can I write like this? I is equals to Q by T. Okay. So I is equals to Q by T. Now, can I write this equation? So Q is, can I write like this? Q is equals to I into T. So bring T this side. What will happen? That is I into T. So now here I got Q equal to what? I into T. So now can I substitute this Q here? We can write. So equation 1. So equation 1 becomes W is equals to V into Q is equals to what? I into T. Correct? Clear? So W is equals to V into I into T. Okay? Yes, sir. So what is the next step? What? V is equals to? Yes, so here we know, here we can use Ohm's law, right? Here we know the we are passing voltage and here current and resistance is there, correct? So that is V is equals to, we know this formula, famous equation, very important relation, V is equals to I into R, Ohm's law, correct? So now can I substitute here? Okay, yes sir. W is equals to I into R into I into T. So here when you multiply here, what we will get? W is equals to I square into R into T. Correct? Yes. Right hand side over. What about left hand side?
So what is nothing but
here
heat is a form of energy.
Heat means what? Energy, right? So heat equal to I square into R into T. But here we got work done equal to I square into R into T. Yes, so in the previous year in the 9th standard you had studied, correct? So that work energy is equals to what? Work done. Here, see, here heat is produced, right? Heat means what? Even heat is also a form of energy. Okay, so now we can say that heat energy which is equal to work done. In the work done chapter you had studied. Okay, clear? So now we can write this work done is equals to heat energy. So finally we can write H is equals to I square. H is equals to I square R into T. So we use this formula for what? To calculate the heat developed in the conductor. Okay. This is a small derivation. I think they won't ask for example, but you study better. Okay. So I will give the notes separate. Okay. Don't worry. I'll give notes. But this formula is very important. So now H is equals to I square into R into T. Okay. This is known as, see, this equation of that formula is known as Joule's law of heating. Okay. This relation is known as Joule's law of heating. So this question is very important for 2 marks. They will ask the state Joule's law of heating or write the relation Joule's law of heating. Yes, now tell me how to define. Just to see this relation using this one, you can define. No need to just observe this formula. Then you can define what is Joule's law of heating. See, when heat arises in the conductor, when heat increases, so when you increase the current or when you increase the resistance, or if you know, right, here, do you know why here we are using T? If you use that, see, when if you use mobile for 3 hours or 4 hours continuously, then more heat arises, right? Why? Because you are taking more time. If you use only for 5 minutes, you won't feel it. But if you use that mobile for 3 to 4 hours, so there you will take more time, right? So that's why if you take more time, then also heat increases. Here, if you increase the current, then heat increases. If you increase resistance, current increases. If you increase the time, then heat increases. Okay, so that's why the heat produced in the conductor, okay, that heat is developed in the conductor is directly proportional to the square of the current and directly proportional to the resistance and directly proportional to the time. Clear? So this is known as Joule's law of heating. Okay. So here heat produced in a resistor or conductor is directly proportional to the square of current for a given resistance, directly proportional to a resistance for a given current, and directly proportional to the time for which the current flows through the resistor. Okay, so no need to add, just keep in mind H is directly proportional to I square. Okay, so you can write this equation of words, right? So E dot vector is directly proportional to the square of the current. Okay, then H is directly proportional to resistance and H is directly proportional to E. Okay, so this is known as Joule's law of heating. Okay, and using this formula we can calculate the heat developed in the conductor. Okay, yes. But here, so this is very simple one. But in your textbook, they have used a different method. Both are same, but they have used a different. Now we'll see that the textbook method. Okay. Now, so once again, consider same diagram. So here, voltage V, current flows through the R, that is I, and resistance R, and Q, number of electrons passes in a given time T. So now the power input by this circuit, okay, that is we can write, we know the formula, right? How to calculate power? Power you have studied in the last year. Power is equals to what? How to calculate the power? Energy upon time, okay, or work done in a given time, correct? So that is W divided by time taken. If you want to calculate the power of one object, so how much work it will do in a given time, so that is work done equal power is equals to work done by time taken. Now see here, so power equal to V by T. Now what is the work done here? What is the work done here? You know, use this formula, say V equal to W by Q, correct? So work done here, the work done from this battery, that is the work done equal to what? V into Q, correct? Now substitute here. So power P is equals to work done, that is V into Q. V into Q divided by T, correct? Now just observe here. Just observe here. What it represents? Q by T, correct, right? So now you can write power V is equals to V into I. Okay, here, but we need this one, right? This relation H is equals to I square into R into T. Okay, yes, here see this formula is also very important. We use this formula to calculate the current. If you want to calculate the power in the circuit, so here you should know voltage and current. When you multiply, you will get the power. Okay, yes. So now here we got P is equals to V into I. Okay, yes. Now how to prove? We need H is equal to I square into R into T. Yes. So now what is the next step? Yes, tell me first. So now here V is equals to what? So use Ohm's law, that is V equal to I into R. So we can write this as Vp is equals to V into, sorry, V is equals to I into R, right? Sorry, I into R into I. Correct? So now P is equals to what? I square into R. Correct? So now this power is, see, you are here, you are getting power P equal to I square into R. If you use that divides for long time, for a time T. Correct? Just imagine you are using for 1 second. Okay? For 1 second, you will get the power as I square into R. So now what about for 10 second, 3, 20 second? I don't know, but I will take time as T. So what about T? That is T into I square into R into T, right? So now this is for, if you use that for a long time T, so then you have to multiply, right? Okay? So then we can write, yes, so then you can write P is equals to I square into R into T. Correct? If you see, this is the power for short time, but if you use for a long time T, long time means if you use for 10 seconds, then you have to multiply into 10. If you use for 20 seconds, then you have to multiply 20 seconds. If you use for 1 hour, then you have to multiply that 1 hour. Okay, that is into 60. It's not 63,600 seconds. Okay. So now we got P equal to I square into R into T, but we need H is equals to H equal to R square into RT, right? Yes, how to write? Think. So here we got P is equals to I square into R into T. Okay, but we need H is equals to I square into R into T. Yes, so tell me what is the answer? Quick. Yes, see here. So now here we got power equal to I square into R into T. You know, I had told right early in the beginning, that only we use only less amount of energy, it is useful for us. The remaining, it will convert into heat. Correct, right? So this heat is finally, this heat is converting into, sorry, this power is converted into or dissipated as heat. So that's why we can write H is equals to I square into R into T. Okay, so here that power. Okay, see here we are using this conductor for what? Just to develop the heat. Okay, so that the entire power, okay, that power it dissipated in that conductor as heat. So that's why H is equals to I square into R into T. I think that's a little bit complicated one. This textbook earlier one was easy. Okay, yes, I give notes, no problem, don't take tension. So finally we got H is equals to I square into R into T. Okay. I will stop here. So tomorrow we will discuss electric power. Okay. And some problems. Thank you.